Hello students, in this particular video I am going to discuss the advanced tree, that is the unit 5 in the data structures and 5. Now first we look at the content in this particular unit, the concept of threaded binary tree, traversal of threaded binary tree, concept of red black tree, AVL tree, B tree, B plus tree and the split trees. So in the previous video, I discussed this threaded binary tree and the traversal in the threaded binary tree. Now I am going ahead with the AVL tree. So we already discussed some questions which are asked in the previous exam, like the problem on AVL trees. Mostly the problems asked on the AVL tree, and the theory questions are asked on the red black trees, split trees, B trees, B plus trees. Okay, and sometimes the question is also asked, numerical question is asked on the red black tree and or the B trees. Okay, so let us go ahead. Before starting with the AVL tree, let us understand what is meant by a balanced tree. So the balanced tree is nothing but a binary search tree that makes the searching easier if it contains half of the elements in the left subtree and almost half elements in the right subtree. It is not possible all the time because it depends on the element inserted. So we'll see the example of unbalanced tree. Unbalanced binary search tree. If you are inserting the elements in the increasing order, so you will getting the right skewed tree. If you are inserting the elements in a decreasing order, you will get the left skewed tree. So this is an unbalanced tree. How you can say it is an unbalanced tree? By using a balance factor. The balance factor is nothing but the height of the left subtree minus the height of the right subtree. So for every node, you have to calculate the balance factor. Balance factor of 10 is 0 minus 4 because there is no left subtree. So it is 0 and the right subtree height is minus 4. It's 4. So 0 minus 4 is minus 4. So balance factor of 12 is minus 3, balance factor of 14 is minus 2, balance factor of 16 is minus 1 and balance factor of 18 is 0. Now for a balanced binary search tree, if you observe, if you are taking the 14 as a middle element or the parent, then the 10 and 12 it goes to the left subtree and 16 and 18 is on the right subtree. So if the height is balanced, let us see the balance factor of each node. So balance factor of 14 is 2 minus 2, that is 0. Balance factor of 10 is 0 minus 1 is minus 1. Then 0 minus 1 is minus 1. For 12 and 18 it is 0. So the balance tree, in the balance tree the searching is depends on the height of the tree. The height changes as the insertion or deletion takes place. The insertion and deletion of the nodes makes the tree unbalanced. Suppose if you are searching an element in the unbalanced tree for 16, then how many comparisons you need? 1, 2, 3 and 4 comparisons. Whereas if you want to search 16 in the balanced binary search tree, you have only 2 comparisons. So the comparison is get reduced in the case of balanced binary search tree as compared to the unbalanced binary search tree. Now let us go ahead with the different kinds of the balanced trees. So there are AVL tree is one solution, B tree, B plus trees, 2, 3 trees, then red black tree and the split tree. These are the options for the balanced binary search tree. Then we will see the AVL tree. AVL tree was named after the Russian scientists J.M. Adelson, Velsky and E.M. Landis. AVL tree is a special kind of balance tree in which balance factor of each node cannot be other than 0, minus 1 or 1. Okay, in the AVL tree, the tree is called as AVL tree if all the nodes has the balance factor 0, 1 or minus 1. Representation of AVL tree. Normally binary search tree is represented as a data, left child and right child, and but in AVL tree you have to add one more component called as a balance factor. The AVL tree is represented as left data, right and balance factor. So the node structure becomes structure node, int data, node star left and right, and integer balance factor. Now we'll see how to build a AVL tree. AVL tree is constructed by the same way applied in the binary search tree. That is, if new element is smaller than root value, then it examines the left subtree, otherwise the right subtree. The balance vector of each node can be 0, 1 or -1. Use different rotation methods to balance the tree. In AVL tree, after performing operations like insertion and deletion, we need to check the balance factor of every node in the tree. And if the tree is unbalanced, if every node satisfies the balance factor condition, then we conclude the operation. Otherwise, we must make it balanced and use the rotation operation to make the tree balanced. So after every insertion and deletion, you have to check the balance factor condition at each node. The balance factor condition is, in AVL tree, the balance factor of every node can be 0, -1 or 1. If you are getting the balance factor other than this value, then you have to apply the rotation to make the tree balanced. Now, what are the different types of rotations in the AVL tree? There are the two types of rotation. One is a single rotation and second is the double rotation. Single rotation is either you have to do the left rotation or right rotation. And in double rotation, you have to apply the combination, that you have to go for a left rotation and the second is right rotation. And the second option is right rotation followed by the left rotation. So LL, RL, LR and RL, these are the short form for these rotations. Now in the next video, I am going to explain this different rotation and will solve one example on the AVL tree. Thank you.